Good morning, grade 9, and welcome to another exciting episode of Reachback. I am your host and narrator for this wonderful adventure, Mr. McDonald. We'll start with question 1. Question 1 was true-false. It gave you this lovely little exponential form expression and asked you, does it equal 4? Well, let's look. The first expression has -2 with no brackets around it with an exponent of 2, which means the opposite of 2 squared, or -4. The next exponential form has -2 with brackets around it, which means it is the base, which means it's used in repeated multiplication, which means it's +4. And then we have this trick question right in here. Yes, there's brackets, but the exponent is inside with the -2, which means it means the same thing as this question. So this and this are the exact same thing. So therefore, it's take away a -4. So if we simplify, and I'll take my highlighter here, if we simplify the first part of this expression, a -4 plus a +4, that is 0. And a 0 take away a -4 is the same thing as adding a +4, which means your answer is 4. Which means this is a true statement. Question 2, without a calculator, what is the square root of 2 1/4? Is it equal to 15 over 10? Well, let's try. Let's see what happens here. So the square root means what fraction times itself was 2 1/4. Now, since our procedure here is to figure out what is our numerator and what is our denominator, we can't do it with mixed fractions. So instead of using a mixed fraction, we're going to change 2 1/4 to an improper fraction. What fraction times itself? It now becomes apparent that 3 times 3 was 9, and 2 times 2 is 4. So therefore, the square root of 2 1/4 is equal to 9 over 4. Oh, 9 over 4. 9 over 2. Oh, sugar cubes. Oh, sugar cubes. Let's do that again. Let's try that one more time. Okay, so it's 9 over 4, which means it's 3 over 2 times 3 over 2. And therefore, the square root of 2 1/4 is equal to 3/2, or 3 over 4. Oh, 3 over 2. Said it again. So here's your question. Are these two fractions equal? Right? Since the square root of this is 3 over 2, is 3 over 2 equal to 15 over 10? Well, let's check. If I multiply the denominator by 5, I get 10. If I multiply the numerator by 5, I get 15. So therefore, 3 over 2 and 15 over 10 are equivalent fractions. And therefore, your answer is true. Aha! Got a lot of you with that one. Question 3 gives a big long string of a polynomial. And it asks you, is this long polynomial equivalent to this small little binomial? In order for us to do that, we need to gather like terms. We'll start with my highest degree terms, which are my x squareds. A -10x squared and a -10x squared is a -20x squared. And right off the bat, I'm like, hang on a second. That's false. Because if I gather the rest here, these expressions are not equal because I got this big old -20x squared. All right, some people might have assumed that that was making a zero pair, but because it's a negative, it actually made it -20x squared, so your answer is false. Question 4, the hundredths number in the pattern is -200. So just like on Mondays, we're going to put the number in the pattern and its value. The first number, the second number, the third number, the fourth number, the 100th number. The value of the first number is 0, the value of the second is -2, the value of the third is -4, and the value of the fourth is -6. So we go here, and we see we're dropping by 2 each time, and we're going up by 1 each time. So the difference in the v, or the difference in the y, divided by the difference in the x, or the difference in the n, equals -2. So in the equation that shows the relationship between the number and the value, the coefficient is -2. I'm going to drop in my first ordered pair, -2 times 1, simplify, and realize that -2 does not equal 1, but a constant of +2 balances the sides. So now we have your equation. The question says, what's the 100th number? So I'm going to take this equation and substitute 100 for its number, because I want to know what the 100th number is, so the 100th n. And I'm going to simplify. And I'm going to realize its value is not -200, but rather -198. And therefore, your answer is false. Question 5. Let's just move this over a bit here. Question 5 gives you the product of the monomial -x times this binomial of 2x minus 7 is equal to this binomial here. Well, let's see. When I multiply using distributive property, -x times -2x is -2x squared, looking good. And -x times -7, well, x times 7 is 7x, and a negative times a negative is a positive. Oh no, it's false. So it is a false statement because it should be a plus 7x, not a subtract. And our last question, in the equation, -1.5x minus 10.5 is equal to 8.5x plus 3.5. The value of x will be positive. So what are we going to do? Well, we're going to solve for x. Now notice that when you start this equation, you have a negative value of x here, and you have a positive value of x here. And what we said was, it's usually easiest to get rid of the x on the side that has the least amount. That allows you to keep a positive coefficient most times, and therefore it keeps it a little bit simpler. So I'm going to add 1.5x to both sides. That's going to create an algebraic zero pair. And we left with -10.5 is equal to 10x plus 3.5. Then I am going to subtract the constant from both sides to start working the isolation. 10x is equal to -14. Divide both sides by 10, and we automatically see that x is going to be negative. It's -1.4, and therefore your answer is false. Okay, hopefully you did all very well on these questions. They were an extension of your Monday Reachback. Don't forget to try Friday's enrichment question. It's a pretty tough one, but to date I haven't received any work from this question yet from any of my students, so I don't know how well Mr. McNeil, Ms. Gerard's, or Mr. Pendleton's students are doing with it. But do make sure you give it a try. They're kind of fun, and they're kind of challenging for you. Good luck to everyone, and stay positive, stay safe, wash your hands, and don't let your boomer parents drive you crazy.